Is it d to the minus rad y dy? Something like that? I don't remember. And you're not helping. So e to the minus rad y. Well, pleasant little problem. Anybody got any bright idea? Let's let t equal rad y. So t squared is y. 2t dt is dy. New limits of integration. When y is 0, t is 0. When y is infinitely large, t is infinitely large. E to the minus t, and then 2t dt. Okay? So I'm going to change things just a little bit because I want this to correspond to one of those table entries so I don't actually have to integrate it. I'm going to write this as t equal minus rad y. Is that okay? Let's see. In that case, I still get t squared equal y and 2b dt equal dy. But something else is going to change if I rewrite that in that fashion. The limits of integration. This is now minus infinity, isn't it?
Wait, why we switch to negative?
And this is e to the plus t.
Why do we change t equals?
You'll see in a moment. Let's just make sure I did this right. When y is 0, t is 0. When y is infinity, t is negative infinity. E to the minus rad y is e to the plus t. 2t dt is still dy. So the question is, well, what the hell did you do that for, Newberry? Because now 2 integrals, 0 to minus infinity, t e to the t dt. I don't have to integrate that now. Why not? Because I got a little thing called the tables at the back of the book. Now hopefully that is one that is in the table. Hopefully it's in the tables I supply on the exam, should I decide to supply some. So tell me, which table entry are we talking about here? Yeah, I was hoping somebody would take a little longer to find it so I could like close my eyes and nap for a minute. But I agree, number 96 is the one we want, where a is equal to 1. So that is t minus 1 e to the t plus c. What did I just say it was?
T minus 1.
Ah, t minus 1 e to the t. Well, I'm going to have limits of integration. Right? So this is the limit as k goes to negative infinity of 2 integrals 0 to k t e to the t dt. Now I can use the formula and not actually have to integrate. So this is the limit as k goes to negative infinity 2 times. And what was the integral of t e to the t? T minus 1 e to the t. And that's from 0 to 0 to k. So now let's plug in k. Limit as k goes to minus infinity. If we plug in k, we get 2, k minus 1 e to the k, minus, and when we plug in 0, we get, well, minus a minus, we get plus 2 plus 2. Does everybody agree with that? If I plug in 0 here, this is minus 2 e to the 0, so minus 2 times 1, but we're subtracting. All right, well, let's let k be minus infinity. What do I get then? Infinity, well, over infinity, right? So I can use L'Hopital's rule. As soon as I write it that way, right? I've got to write this now. What I'm going to do is, well, this is a constant, right? There's no k's in that, there's no t's in that, so I have 2 plus the limit as k goes to negative infinity to k minus 1 over e to the minus k. Now we have infinity on, well, minus infinity on top, plus infinity on bottom, and we can use L'Hopital's rule. 2 plus limit as k goes to minus infinity, derivative of the top, 2, over derivative of the bottom, minus e to the minus k. Let's now let k be infinity. We get 2 plus, well, let's see, minus infinity, minus a minus is plus, so e to the infinity, this is all just 0. So it looks like the answer is 2. I could write. And if I didn't have the table entry to copy there, I would have had to have done an integration by parts in addition to everything else that I did.
How'd you get u to the negative k?
Pardon me?
Did you get u to the negative k?
Which negative k? There's a lot of k's.
Which color?
The black. The right side.
Red side black?
E to the k in the numerator is e to the minus k in the denominator. Questions?
Since it's a negative infinity, wouldn't the top be a negative infinity?
What?
Wouldn't the top of the fraction be a negative infinity?
Yeah.
But then
L'Hopital's rule still applies. It can be infinity over infinity, or minus infinity over plus infinity, or plus infinity over minus infinity, or they could both be negative infinity. Any combination, the sign, S-I-G-N, sign does not matter. Question?